I don't know, I don't know how many of you saw it. Let's see if I still have it up here. Yeah, these are correct. And I almost can't believe I forgot to mention this. Look at what's down here. A sub 2, B sub 1, A sub 1, B sub 1. Now let's look over here at, hold on. This is, oh, let me see here. Look at for Y and X. Here's A sub 1, B sub 2. See that? That's there for X. And this is here. Now, I've pointed this out before, but I want to point this out again. Just watch this for a second. Watch. Or you tell me, how much is 5 minus 1? 4. No question about it, right? What's 1 minus 5? Negative 4. No doubt about it. If you have a difference, if you have one thing and you're subtracting another, and for some reason, let's just say for some reason, you want to switch them around, it becomes a negative of what it was. So I could write this like this. Now what I'm really getting at is this. If you have star minus W, that's the same thing as negative W minus star. This right here is one of these weird tricks that comes up every once in a while. It just does. You'll have this, but you'll want this. So you'll have, let's say you have star minus W and you're thinking, I really wanted it the other way around. You can do that by putting a negative sign out front. In a way, look at this denominator. I really want this. I really want this. So how can I get that? Well, I can just flip it around, put a negative sign out in front. So I can say negative A sub 1, B sub 2 minus A sub 2, B sub 1. Now that's the negative of the determinant. So now I said some notation was coming up. I know this is a lot of stuff here, especially if you haven't seen it before. Here, let's say we have, let's just, let's go off to the side here, and let's say that we have any old matrix. Let me just use the symbol star W. Is this visible on screen? Yeah. Star W, T, and I don't know, capital H. There's a matrix. How do we denote, how do we write the determinant of a matrix? One way is to put, right here, DET for determinant. But another way is to replace the brackets with vertical lines. And this indicates the determinant. So the determinant of a 2 by 2 matrix, we're formally declaring. We're saying, oh, what is it? This is what it is. Now, when you formally declare something or give a definition for something in mathematics, you're not proving anything. You're not just, so for example, what is a face card worth in the game of blackjack? It's worth 10. Why? Because. What is a field goal worth in football? 3. Why? Because it's a rule of the game. It's just a rule of the game. That is the reason why. So we declare that the determinant is star times H minus T times W. This right here is the definition of the determinant of a 2 by 2 matrix. And notice now we can erase this. Well, we have to have a little bit more notation. Oh, geez, I know, it starts building up. Well, this is how you write this. This is how you write that. Well, remember this, remember that. It kind of is a lot, I suppose. Look at this original system up here. I want to write this down. Capital D for a determinant. The determinant of this system, the original system. Here, let me erase this stuff. The less visual we have. Too much stuff on the board here. Get rid of this here. There we go. Okay. Look at the original system right there. What's the determinant of the original system? And the idea is that it is a sub 1, b sub 2, minus a sub 2, b sub 1. It's the determinant of the coefficients of the variables. So, just forget about this, and it's really those coefficients. Here's another thing. D sub x, D for determinant. X in the following sentence. Now, there's two ways to do this, and they're the same. And some people do it one way, and some people do it another way. So it's the same thing. Is there an advantage to doing it one way or the other? I could see pros and cons of both. Okay? So the determinant of x is, well, look at this top business right here. B sub 1, C sub 2. Well, you know what? Look, who likes writing negative signs in denominators? And the answer is nobody. So instead of writing this negative sign down here, it's customary, traditional, to write it up there. Now that's the same thing. That kind of goes back to your understanding of fractions right there, right? I can't resist this. So negative 2/3 is the same thing as negative 2/3 is the same thing as 2 over negative 3. Those are all the same thing. It's three ways of writing the same thing. I can't do anything about that, but it's the same thing. Okay, so look what I have up here. I have this determinant, the determinant of this. Get rid of the y, but there, look. B sub 1, B sub 2, C sub 1, C sub 2. Except there's a negative sign out in front. So this is negative of B sub 1, C sub 2, minus B sub 2, C sub 1. And then D sub y is this numerator right here. A sub 1, C sub 2, minus A sub 2, C sub 1. I mean, I just feel like this is a lot of stuff, but it is what it is, as the expression goes. And I can't really do anything about that. And what this means is now we have a formula for x and y. Yeah. So where should I write it here? I'll write it over here. So x is equal to this, except there's a negative sign there, and y is equal to this. And this right here is called Cramer's rule. Cramer's rule. Which I suppose, when you write it like this, is a fairly nice, compact way of writing it, and there's kind of a nice pattern to it. That's not how your book writes it. Your book is right. Your book is not wrong. So let me see. Let me erase a couple. So look, do you have to memorize this? You should, but if you don't, okay. And let's face it, how am I going to know anyways? But that's Cramer's rule. Now, there's a different way, and I don't know if more people write it this way or the way I'm going to show you right now. I don't really know, and it doesn't really matter. But let's multiply. Just look for a second. Look at x right here. Let's multiply this out. You get negative this and then plus this, and so you could write it like this. Just the numerator. I only want to write the numerator here. So we get b sub 2, c sub 1 minus b sub 1, c sub 2. B sub 2, C sub 1 minus this. What does that look like over here? It looks like this minus this. This minus this. But I could write this like this. C sub 1, B sub 2 minus C sub 2, B sub 1. And then someone realized, or somebody noticed, that this right here, this is the determinant of the following matrix. C sub 1, C sub 2, B sub 1, B sub 2. Right? Because you have this times this minus this times this. Now, look at this matrix here. Just consider the matrix, the matrix itself. this matrix. Where would you get this matrix? Or how would you get this matrix from this original system? Well, you would get it by, if you just replace this column, the coefficient column, a sub 1, a sub 2, you replace it with this. So bring this over and replace it here. And that's another way to look at this. Now you get the same thing. So let's go ahead and do, let's do a problem. Let's do a problem with Cramer's rule. See if we can remember Cramer's rule. Hey, I'll leave it up here like this. Let me write down the problem there. Of course, right now I'm trying to think, should we do a problem that comes out quote unquote nice, or should we do a more natural problem? You know, let's do one that comes out nice. So again, behind the scenes, the making of, you're not supposed to see this, but let's suppose x is 3 and y is 5. I mean, you're not supposed to know that. That's what we're going to solve for. But let's make up a nice problem here. Let's say we have 4x minus 2y. And what would that be? That would be what? 12. Help me out on this. Minus 10. So 2. And then what if we had, let's say, 3x? How about negative 5x plus 4y? What would that give us? Negative 15 plus, negative 15 plus 20 is 5. So there's our problem. We weren't supposed to see that over here. Let's just double check. This is a classic place where I make silly mistakes. But arithmetic's okay. Negative 5x is what? Negative 15? And negative 15, 20 is 5. Okay, we weren't supposed to see that. Let's use Cramer's rule. It doesn't matter the order in which. Look, here's the ingredients, or here's the pieces of the puzzle we have to calculate. We have to calculate this determinant, and this determinant. So not in any particular order, but let's look at this determinant right here. Now, what is it? That's the determinant of the coefficient matrix. So 4, negative 2, negative 5, 4. How do we calculate this determinant? We do 4 times 4. Here, I'll write it out. 4 times 4 minus, I want to be careful with all the negative signs here, minus negative 5 times negative 2. So what does this give here? 16 minus 10. So that's 6. Something I want you to notice. Are there a lot of calculations? Yes, but they're extremely easy. So what we're getting with Cramer's rule is we're getting, well, it's not a win-win. It's a trade-off. What we're getting are very simple steps. If you believe in these formulas, it's a funny word to use, but we verified these formulas, justified these formulas. I essentially showed you proof for these formulas that derive them. Once you have these formulas, this is incredibly easy. You just have to be able to add, subtract, divide, and multiply. Look, I didn't even do algebra. I didn't do any algebra. But it's a lot of steps. Now notice, that's really nice if you're a computer, because if you're a computer, you don't mind doing a lot of steps. That's not a problem for you. Recognizing patterns is a greater difficulty. Okay, so there's D. Let's find D, the determinant for X. Again, I'm going back and forth to the way the book says to do it and the way I traditionally do it. They're the same thing. Again, it doesn't make a difference. But let's just find the determinant of the matrix we get by deleting the X column. Now, what would I have here? We delete the X column. Negative 2, 2. And 4, 5. Okay, let's go ahead and do that. So I'll write it out here. Negative 2, 5 minus 4 times 2. Right? It's this times this minus this times this. So this is, what do we have? Negative 10 minus 8, so negative 18. Now notice when I do, well, let's just go ahead and get X right now. Let's go ahead and get X. So what is X according to this formula? It's negative this. So negative 18 divided by D, which was 6. So X is 3. As I recall, that's what it was. We were supposed to know that, but fine, that's what it was. Now to get Y, we just have to get D sub Y. So the determinant the determinant for the y column. Get rid of y. What do we have left here? Let me make sure I don't cover up anything I'm not supposed to. There we go. So 4, 2, negative 5, 5. 4, 2, negative 5, 5. Okay, I'll write the whole thing down here. So 4 times 5 minus negative 5 times 2. This is 20 plus 10. So this is 30. So what is y? Y, is that on screen? Yeah, barely. What is y? According to Cramer's rule, it's d sub y, which we just said somewhere there, 30, divided by d, which was 6, and y equals 5. Okay, I should probably do this slight different way the book does it. It's so minor, it's barely worth mentioning, but I better mention it. Okay, let me erase this. The way the book does is it says what you should do to find d sub x is that you should switch or replace this column with this column for d sub x. Replace the x column with just this plain old coefficient column over here. Later on, you're going to find out that we can refer to these columns and also rows, but as vectors, but not in this course, so I shouldn't even have said that. Okay. So let me go ahead and do that. So we have, I'm going to replace this column with this column. So 2, 5, we'll leave the y's alone, negative 2, 4. And then what do we get for the determinant here? Well, 2 times 4 minus 5 times negative 2, which is give us 8 plus 10, which is 18. Now, if you do it that way, you don't need this, or you shouldn't have this negative sign here. And then you'd have 18 divided by what was capital D. I don't know, I had it written down somewhere, but I'm pretty sure it was 3. Or it was 6. Yeah, it was 6. And 18 divided by 6 is 3. So we'll get the same answer either way. Now, this can be confusing. I get it, because if you look at 10 different books or you go to 10 different videos, some people will do it one way and some people will do it another way. I honestly don't care which way you do it. Look, it's not, like I said, it's not a win-win, because on the one hand, it seems a bit awkward to have this negative sign here. On the other hand, it seems a bit awkward to have to replace one column with another column, or to actually move it over here, because if I just leave it like this, then you get the negative of the number that we're looking for. Now, in the next video, we're going to do 3 equations and 3 unknowns by determinants. Maybe we should skip that. Now let's do that. We'll do that. Most people like doing that. I don't really like doing that, but a lot of people love doing it. But let me sign out for this particular video, and then when I come back, let me have some. What time is it? Maybe I'll have some lunch, and then we'll do a 3x3 system via Cramer's rule, which uses determinants for a 3x3 matrix. Which is a little bit more complicated. Okay.